Okay, our second proof, you can pause the video and get a good shot of what this is saying. Okay, now you're unpaused. The goal here, I didn't write down, was to prove that these two triangles are congruent. So at the very end of my proof, this will be the last thing that I write, at the very bottom, trying to prove the triangle SAB is congruent to triangle REB. Oops. Triangle REB. All right, so here we go. Very first thing I need to do is take a look at the givens and mark them in my picture. And like I said, this is almost like you're buying things, buying parts, or buying facts with a given fact. So this is like your money. RE is perpendicular to AE is perpendicular to RE. AE is perpendicular to RE. That means between the two of those, there's going to be a right angle, angle E. So I can buy that fact with that money, with this money here, that AE makes a right angle or is perpendicular to SA. So this and this also are perpendicular, so I can buy a right angle with that. Now let me write that down. Angle E and angle A are what type of angle? They are right angles. The reason why I know that's true, well, how could I buy that fact? I buy that fact with this money up here, that these are perpendicular segments. So I will just write down, just like the previous example, I would write down what perpendicular means, or what perpendicular does. Perpendicular segments form what kind of angles? Right angles. Now let's see if you learned from the last proof. Now that I know that E and A are right angles, that's very good to know. I can take it one step further. If E and A are right angles, what has to be true directly from that fact? E and A are both 90 degrees, and I know that angle E is congruent to angle A. How about the reason why? Can you get it right without looking back at the previous example? If you can't, then take a look at the previous example. Why are those two right angles congruent? The cheapest and quickest way to write it out is because of all right angles are congruent. Notice that on the right-hand side of my proof, I never talk about the specific picture with the letters. Anything that I write on the right-hand side is just talking about, in general, what's true. On the left-hand side, that's when I talk about the picture only. So you should steer away from talking about the letters on the right-hand side. The reasons are very general. The statements are very specific to the picture. So this information here won't drift off to the other side. Okay, I've got that marked on my picture, so I've got two angles that match up. That's a start. I still haven't spent all my money because there's one more given that they're providing me with. That SR bisects AE. When you're dealing with bisectors, you should know that bisectors cut things in half. And this is a segment cutting another segment in half. I like to think of it as a knife or a saw that's cutting something in half. So SR is the saw that is cutting this piece of wood, AE, in half. So looking at my picture, AE is the wood, SR is the blade that's cutting through it. That must mean that AB is the same as EB. And that's what I can buy with that fact number 3. Because the bisector exists, I can actually buy something with it. So what do bisectors do? Segment bisectors make two congruent segments. You could write definition of a segment bisector. You could say a bisector cuts a segment in half. I like this one. A bisector makes two congruent segments. So that's in general what's happening. In the picture, it means for us that AB is exactly the same as EB. Okay, so I can mark it down in my picture with an S. Got two sides that match up, two angles that match up. I don't have enough information to prove that the triangles are congruent because all I have is an angle and a side and an angle and a side. So I've spent all my money. All three of these facts have been used up. There's only one thing left to do is to go into the picture and see if I can get something from just the picture alone. And this is where you have to be careful not to say something that looks true and then you won't have a reason for why it actually is true. So, I mean, there are things here that actually look true. Like, it does look true that from A to S looks the same as R to E. But there's no reason next that you can actually put to the right of why that is actually true. When you've run out of given information and you're still looking for one more fact, these are some popular facts that could come up. The most popular ones I can think of are the vertical angles and the reflexive property. I showed you on the first example the reflexive property, how that occurs. And this one here where these angles are being formed by two intersecting lines, that's your last fact. Those are vertical angles and they're guaranteed to be exactly the same. So this angle here has to be exactly the same as this angle here. And that's what I can write down. I can write down that angle ABS, angle ABS, is congruent to angle EBR. You always got to be careful as a math teacher not to put down letters that spell a dirty word. So we're good there. Angle EBR. And then the reason would be because they were vertical angles. So you'd write out vertical angles are congruent. And you can go back to the picture and take one last look at it. We've just gotten two more angles that match up. So I see a pattern of congruence here. An angle side angle matching with an angle side angle. So that puts me on the last line of the proof. Now I know that the triangles have to be congruent. So triangle SAB has to be the same as triangle REB. And the reason is because of the angle side angle. All right, that's the end of the proof. I want to take you just one little step a little bit farther. I got another minute or so. So here it is. That's the whole thing from start to finish. You can copy it down, pause the video if you want to, replay it if you need to. Here are some things just worth mentioning. When you get to the very end, trying to prove that two triangles are congruent, the only thing that's allowed to be over here are one of those 5 reasons for congruence. I've even known some students to actually write this down, that they know that at the end they have to get one of these 5 possibilities to show up. And then what they do is look at the picture and decide which one doesn't work. It wouldn't be side, side, side. We have got 2 angles, so it couldn't be side, angle, side. We're down to these 3 possibilities. They are right triangles. And when there's right triangles, there's always a chance that it could be hypotenuse leg. But I don't have the hypotenuse in either. So I know that for sure it can't be that choice. And then looking at the pattern, it's an A with an S in between and another A. So it would have to be angle side angle and not the other one. All right, so final thoughts on the proof. Once we actually have that the triangles are congruent, we've got a very powerful thing in the palm of our hands. It's like winning the lottery or winning the jackpot. Once we know that the triangles are congruent, then we can say that anything else that looks congruent has to be congruent. And this can be written in the proof like this. Suppose that instead of asking us to prove that the triangles are congruent, suppose they wanted us to prove that SA was identical to RE. The only thing that would change in the proof, you would run through the entire thing just like this, just as we have here, proving that the triangles are congruent, and then you just add on one more step to your proof. Once I get the triangles are congruent, then I can say that the parts, other parts, must be exactly the same. So S to A is exactly the same as R to E. And the reason for something like that, I have enough room here, good. The reason for something like that is abbreviated CPC-TC. And CPC-TC is a quick way to actually say that since the triangles are congruent, the matching parts will still have to be congruent. Now I'll write it down here. CPC-TC stands for corresponding parts of congruent triangles are congruent. It's nice to know what it actually stands for. It's actually very important. Okay, the corresponding parts of congruent triangles are congruent. Okay, and what it means is that once the triangles are congruent, we know that every single part in this triangle has a match to the other triangle. If you actually forgot the abbreviation CPC-TC, or even forgot what it means, or how to write it this way, you could still score points and get this right by saying, in words, you'd have to write out a full sentence instead of just these 5 letters here. You'd have to write something like, now that I know that both triangles are congruent, then it means that all the parts of one triangle have a matching or congruent part in the other triangle. Which is all right to say. I mean, you're communicating your ideas fully, but if you can abbreviate it, it actually saves you a little time. And you got to be familiar with that code, CPC-TC. So keep on working really hard. I know there's been 2 videos, episode 4 and 5, that will help you get ready for the test, which is happening soon. Good luck.